Hello everyone, welcome to Hydropower. Today, in this lecture we will talk about the settling basin, its types and purpose as well as the components of settling basin along with figure and finally the design of settling basin. So, let's start with the settling basin, an essential component in water treatment and sediment control. A settling basin is a major engineered structure used in various industries, including hydropower, wastewater treatment, and mining. It plays a key role in removing suspended particles from water, resulting in cleaner effluent. Let's talk furthermore on settling basin in hydropower. Types of settling basin: sedimentation basins designed to remove suspended sediments, commonly used in hydropower plants. Continuous flushing settling basin. It features a unique mechanism that regularly flushes out settled solids to maintain the basin's efficiency. This design prevents the accumulation of sediments, ensuring the quality of treated water. Discontinuous settling basin. It is a water treatment structure that removes suspended solids in batches, not continuously. It fills with water, allows settling, and then drains to remove settled solids. Conventional type settling basin. It is a standard water treatment system that continuously removes suspended solids from water by letting them settle to the bottom. It's widely used in applications like hydropower projects treatment to improve water quality. Hopper-type settling basin. Hopper-type settling basin is used to efficiently collect and remove sediment and debris from incoming water. Its hopper-shaped design facilitates easy removal of heavier particles, protecting the hydropower turbines from damage and ensuring smooth operation. Bieri-type settling basin. In the Bieri-type settling basin, there is a shutter mechanism at the bottom, consisting of two plates with a series of openings. One plate remains fixed, while the other can be moved horizontally. Flushing occurs when the openings in each plate align. Serpent sediment sluicing settling basin. The serpent sediment sluicing settling basin features one or more flushing channels situated at its bottom, connected to the basin through a longitudinal slot. Split and settle settling basin. The sediment concentration is uneven across the cross-section of a water conduit. Purpose of settling basin: sediment removal. Separate and remove suspended solids, sediments, and particulate matter, improving water quality. Particle settling. Facilitate the settling of suspended particles and sediments, preventing downstream transport. Water clarification: allow particles to settle, resulting in clearer effluent. Components of settling basins: inlet structure, U.S. transition. Where water enters the basin, and this may include baffles or mechanisms to distribute flow evenly. Settling zone or desettling. Main portion of the basin where sedimentation occurs, designed to slow down water flow for particle settling. Outlet structure, D.S. transition. Where treated water exits the basin, it may include weirs or other controls to maintain water levels. Sludge collection system. In some basins, a system for collecting settled sediment, known as sludge, is present. This collected sludge can be periodically removed. Overflow weir, flushing chamber. To prevent the basin from overflowing during heavy rains or excessive inflow, an overflow weir may be included. At some places this is also known as spillway. Settling basin, particle approach. In the particle approach, we focus on the settling velocity of individual particles to determine basin size and design parameters. This allows us to optimize the basin for efficient particle removal. The particle approach can be determined by below process. Settling basin, concentration approach. In the concentration approach, our goal is to achieve a target outlet particle concentration. By focusing on concentration, we can design the basin to meet specific water treatment and sediment removal needs. The concentration approach can be determined by below process. Designing a settling basin. The design of a settling basin involves considerations like the desired removal efficiency, settling velocity of particles, and flow rate. For design of settling basin, following parameters need to be calculated by the different relations, so let's have a look on all of those parameters. First, calculate the surface area A using the formula given. A required surface area of a settling basin. W target sediment particles size with a fall velocity. Q equals design flow rate. K equals coefficient of turbulence. Now, calculate L and B using the relation L B equals 3 to 10. A equals LB and check the necessary length and width. Now, calculate limiting flow velocity in the basin in m/sec with given formula, where the maximum horizontal velocity of flow should not greater than 0.3 meters/sec. Now, calculate depth of the basin using the formula with given formula. Now check the calculated value of L, B, H using formula and check the data with the graph. Now check the efficiency of the settled particle using Hazen's, Camp's and Vetter's methods. Compute the sediment depth in the basin using the formula. Now calculate the length of the basin considering turbulence effect. Designing a settling basin, flexibility and efficiency. The particle and concentration approaches provide flexibility in designing settling basins for different water treatment and sediment removal needs. Engineers use these methods to determine the required basin size and dimensions to achieve the desired particle removal efficiency or outlet concentration. And this much for today. We will come with a new video. Till then, keep on watching our videos and don't forget to subscribe our channel. Thank you.